Everyone, I will be sharing one link. Please open this link. So let us do the task number 1. And this file is for creating the service account. So I'm just giving the cat command so that you can see what is present in it. So this is the content of this service account YAML file. This is the YAML file, which can be used in several other tools also. Now I am running. So my service account got created. Service account EKS admin got created. Okay, so this account is for, this command is for, we are redirecting our port 443 to 10443. So we will be able to view our dashboard on 10443. Let us check it. 10443 display port. After that, just execute these commands. We will come to know what are the nodes present in our cluster. So these are the two nodes which are executing. This is the control plane and one is node 1. So there are two nodes. One is control plane and the other is node 1. And cluster info. So this is our cluster info. It is running on the port address of this is our localhost IP and this is the URL. So please do the task till task number 2 and later on we can proceed with task number 3 and further.
These services, nothing is displayed here, sir.
Have you executed your commands properly? Refresh this tab. Refresh your tab. Rerun the commands, Vishnu. Close this dashboard and refresh your Katagoda session and try to rerun it.
Hello. Hello, sir. Hello.
Vishnu, let me try it from my end once again, and I will let you know it.
Okay, sir.
Vishnu, while starting a Kubernetes session, please wait for at least 1 or 2 minutes so that it is going to execute and start Kubernetes cluster. So it was inbuilt scenario which was given from Katakoda session. So try to execute it after it gives echo message like environment is ready. There will be a message like your environment is ready. Proceed with activities. After that only you try to execute the command. I think there is no problem. I re-executed it once again, and it seems that there was no issue. Okay, let us move with the task number 3.
Hello, sir.
So, yeah, Vishnu, tell me.
Sir, where it comes, environment is ready in the terminal, sir.
Yes, in the terminal only. If you just reload the session of Katakoda, then it may take
Sir.
some time, at least 1 or 2 minutes, and you can see the message.
Sir. Okay, sir.
Okay, let us move on. Task number 3. I will share my screen. The next pod is created. So it is in running state now. We are redirecting it to port 80. Default port of Nginx is 8080, right? Okay. So first one and the second one both are on running state. First one is default port 8080 and the second one is port number 80. So let us delete this port and we will be executing the same in the next task also. Okay, so there are no ports. Task number 4. So what this command does is like it will be taking the image Tomcat. I mean, it will be taking the Tomcat image and it will be creating one pod. So that is the thing we have done. kubectl get pods in a sense. It has created one container. R1 pod. Next, deployment. So we are going to create replicas of 10. Paste. So it is creating the replica sets. So we have to execute the next command immediately so that we will be able to see this output. Next. Now we are scaling down it to 5. Paste. Let's example. So it is deleting the remaining 5. 1, 2, 3, 4, 5. So remaining 5 are, I mean, the replica set in the sense, it will maintain the number of replica sets whatever we are giving. So now we have given only 5 number, but that is the reason there are only 5 pods. Is it clear? Next, in the task number 5, we are going to execute. Okay, execute till task number 4, and further we can move on. Task number 3 and task number 4. We'll look into it tomorrow. I'm doing it from the beginning. Vishnu, do one thing, post the error. I mean, post the error in Slack in DevOps Cloud. See, if you are facing error, try to re-execute it. So this is the third time I am executing, but there is no error from my end. But let us post it to Slack so that we will come to know what might be the error. So till task 4 is done, right? Now we are external IP. Okay, okay. IP space. What is the IP? 172.18.04. Okay, this is the IP 01. Paste. Okay. So once you are done with task number 4, try to re-execute the command with task number 5. Task number 5 is nothing but we are exposing the default port number 8082 31000. So let us try that. So it is available on 31000. Let us try 31000. It is there. 30891. So that is the I mean the port number whatever we are exposing here will not be reachable to the outside world because it is an pod, and pod port number will pod or node, so that port will not be exposed to the outside world. Only cluster port will be, we will be able to reach our Kubernetes dashboard or Kubernetes services using cluster port or cluster IP only. So that is the reason I'm not able to reach out here. So this is the replica set we have created. So here we have executed to export the port under 31000. Next, let us do this task number 6. Paste. Okay. So the second service Tomcat2 is exposed on 32000. Describe. Paste. So this is the info of the Tomcat service whichever we have created. So this is the cluster IP, and this is our node IP. So cluster IP is different and node IP is different. This is the host machine IP. So these two are different, and so if you see here cluster IP, this is the cluster IP. This is the port on which the service will be available, and all the services whatever we are deploying on the Kubernetes cluster, that will be under the pods. It will not come under the master cluster. The master node. It will come under the node machines only, and under node machines there will be pods, and inside pods there will be the container. So the container is placed under the pods or the nodes. So this port will not be exposed to the outside world, and the port under the cluster only will be exposed to the outside world. And the node port, so node port, what it will do is like to communicate internally with some other node or to with the cluster, this node port is used. So in the same way, execute this, and Tomcat. Okay, see here, it is different now. The command first what we executed is for the cluster type of service, and this is the node port. Inside cluster there will be nodes. kubectl descript tomcat here from here. So here, if you see external traffic policy, so to communicate with the outside world, only cluster will be used. No nodes nor node port will be exposed to the outside world. Okay, so do till task number 6, task 5 and task 6. Soon after completing task number 4, do these two tasks, task number 5 and 6, and let's move on. Okay, okay. Okay, thank you, Rizwana. If you are done with task number 6, please post in Slack so that we can continue with the remaining task. In the task number 7, I don't think task 8 is task number 8. Sorry, task number 8. Okay. So this is the content of our application, Hello application, which we are going to create now. So the replica. So till now we have executed only the commands, in the sense we have created only using commands directly, but now we have written all the content in a file and we are now going to deploy it. So see, kind is deployment, and the name of the application is like Hello World, and load balance example and replica set is 5. Okay, 1 second. Okay, so container port is 88. We are assigning the container port, and the protocol is TCP. TCP is nothing but transfer control protocol. So here this is the information, and coming to the image is from, we are fetching the image from somewhere else, I mean from some other source, like, okay. So let us try to execute the same. So hello world is created and the replica set is 5. So this is the port number and image ID which we are going to, I mean which we have created. This is the, I mean, blueprint. So replica 5 desired, 5 total and available. Okay, these are the 5 replicas which we have created, and there are 5 containers in the sense based on the replica set. Containers or pods will be created and it will be executed based on the request we are giving the replica set. And if for suppose if any of the pod or any of the container is having some image or some error or some facing some any of the issues, then what Kubernetes will do like is Kubernetes cluster will take care of the repaired pod or repaired container, and it will terminate that, and instead of the same it will be creating the new one with the same configuration, so there is no need to monitor each and every time. So this is the basic advantage of Kubernetes. And when it comes to Docker, whatever we want, but when there is a problem in the container, there will be no monitoring kind of thing in Docker. So this is the advantage of Kubernetes. So it will be in manageable state, and how many pods you see based on the load or based on the traffic on your application, you can create the replica set, and that number of pods will be created and maintained at any point of time. And if you are facing any, I mean, if the pod is facing any issues, then the same pod, I mean, the repeat pod will be terminated, or will be created in the same place. So there will be no problem based on our, I mean, see, for example, if traffic is, for example, per second, it was around 1 lakh requests are coming into our application. Then at this particular point of time, if our replica set is 10, and based on the functions what we have created, I mean, see, one more thing is like the why we are going into the microservices is like based on the functionality. So some developers will be writing the front end code, and some other developers will be writing the back end code in Java. And there will be different functions. So different functions of the code will be deployed on different containers. So the basic scenario of containers is like, see, for example, if developer A to developer Z has written some code, and if a code Z, I mean, if a code M has some problem, and the same container is not, I mean, the same container is not coming up, and while running the application, there might be an issue. So what they will do like is, so they will just report the same thing to the developer, and the developer will be checking the container. I mean, developer will be checking the container, and he will be on the server right from A to function. I mean, we can just stop that, and we can do the remaining stuff, and we can just recreate one more. So this is the basic scenario, or basic example, or basic advantage of why people are moving into microservices. For example, if you are going into Tomcat, then what you have to do is like, see, entire application, all the functions of the application will be deployed on same container or same Tomcat. And if there was a problem from developer end, then you have to shut down the Tomcat server, and you have to debug the code from starting from the beginning and till end, and you have to make R&D of it, and do the task. So that is quite complex in the real world. So this is the reason everyone is moving into Kubernetes or microservices. So do the task number 8.